Hey guys, it's Miss Miklos. I apologize in advance. I'm sick while I'm making this, so my voice is kind of weird. But today we are starting Chapter 2, and Chapter 2 is going to deal with a lot of concepts that you're familiar with, but we're also going to start kind of delving into some of the tougher Algebra 2 concepts, and the major focus of this first lesson is what we call a function. Now, back in Algebra 1, some of you guys learned about functions and some of you guys did not. By the way, do you like functions? Okay, it's going to be fun. But, so some of you guys know about this, some of you guys don't. But regardless, we're going to learn some important stuff today. So the first two definitions that we're going to talk about are what is a function and what is a relation. First, I want to start with the definition of a relation. A relation is any set of ordered pairs. And when we hear ordered pairs, we normally just think of actually having an ordered pair with an xy value. But this could be in the form of an equation, in the form of a graph. So any set of ordered pairs is a relation. A function is a specific type of relation in which each input has only one output. And that really is the key thing, that there is only one output. And before we start talking about all the math type stuff about this, we're going to actually see where we see some functions in real life. For all you sports fans out there, I actually think sports are a great way that we can see inputs and outputs in real life. So, this morning when I opened up the newspaper, one of the first things I saw was OC Varsity. So we're going to use some football stats to talk about input and output. So last night, Orange Lutheran won our first game of the season. And when I looked in the paper, our input was our Orange Lutheran quarterback, and the output was how many yards they passed. So last night, our Orange Lutheran quarterback passed for 125 yards, okay? Now, this input, our quarterback, only has this one output of passing yards. Now, is it possible that more than one quarterback last night threw for 125 yards? Definitely. But our quarterback only has one output. They only have one amount of yards that they passed last night. The second example I'm going to use is another sports analogy. If you guys don't know, I am a huge Angels fan, so we're going to use the Angels' best player this season. And this morning when I looked up Mike Trout's stats, it told me that his batting average was .331. Okay, so once again, this is telling me Mike Trout is the input. His output is a batting average. That is the only batting average he has at this point in time. Is it okay for more than one player to bat .331? Definitely. So more than one input could go to the output, but Mike Trout only has one batting average. The next one I want to talk about is for all of you future drivers. Okay, if you guys are lucky enough to have your permit already, you know that your car has a specific license number. This specific license plate number will identify your specific car. Okay, so each license plate number goes to one specific address. However, if you are in a house with more than one adult that drives, my guess is you have more than one license plate that goes to the same address. However, this one input only has one exact output. The last example I'm going to go through has to do with weather. I always look up the weather on my phone when I'm trying to figure out what to wear for the day. Like today, it's supposed to be like 100 degrees again or something. So when I look up a specific time of day, it gives me a very specific temperature. Now, it's okay if it's the same temperature multiple times throughout the day, but at 3 o'clock or at 5 o'clock at one specific time, there will only be one output. So hopefully this gives you a little perspective of what functions are like in real life. The next two definitions we're going to talk about are domain and range, and we use these terms quite a bit. Our domain represents all the x values, okay, and I'm using x value because that's what we often use in math. We call this the input. We also call it the independent variable. So if you're doing some sort of lab in chem, you know that you control the independent variable. That would be our domain. One important thing about the domain, just know that the domain can never cause division of 0 or a square root of a negative number. Okay, so domain x value. The range represents all the y values. This is the output, or what we call the dependent variable. This value depends on what our x value or our input is. We often like to think about our functions as being like a machine. Okay, whenever we put our input into this machine, this same thing always comes out. Okay, so each input only has one output. Each x value only has one y value. And we're going to talk about 3 tests, and I'm actually going to add on a 4th one just to raise our level of intelligence. But three tests to see if something is not a function. The first one is if the x value repeats. We use this with ordered pairs, and we can just look at the ordered pairs. If I see that we had something like 2, 3, and 2, negative 4, we would say this is not a function because this x value of 2 is repeating. It's going to more than one y value. So that is our first test. If we have ordered pairs, by far the easiest thing to do. Our next test is called mapping. We also use this with ordered pairs. And the way that this specifically works is we will have one oval shape that deals with all the domains. So D represents domain, and one oval shape that represents all the range. Then we'll put all the domain numbers in, all the range numbers in, and I will draw arrows to map, okay, that this x value goes to that y value. This x value goes to that y value. Now, something is not a function if there is more than one arrow coming from the same number in the domain. And the reason being, this would tell me that a number in here is mapping or has more than one output, so it's mapping to more than one y value. We know each x value can only have one y value. Our third test is what we call the vertical line test, and this is something that we use with graphs. Okay, we know a vertical line goes straight up and down, so what we are going to do here is take a vertical line, okay, and it could either be your pencil, your stylus, your finger, whatever you want. And we're going to go across the function, and if my vertical line, okay, and we're pretending this arrow here is a vertical line, if my vertical line touches any 2 points at the same time, it is not a function. So we would say this first graph is a function. It passes our vertical line test. Our second one, when I go straight across, all of a sudden we hit a point here, and I realize, uh-oh, there is more than one y value for this specific x value. Okay, our vertical line touches 2 points at the same time. So we would say this is not a function because of this point here and this point here. Okay, and we see that that happens at numerous times throughout here. So that is our vertical line test. We use that with graphs. Okay, and our test number 4, not problem number 4. We haven't learned everything mathematically to do this yet, but it would be dealing with isolating y in an equation and making sure that there's only one output. Okay, so this is something that we would use with equations, and let me kind of demonstrate. These are 2 types of equations that we will be working with in the future in this class. Okay, this first one actually is a circle, but even if I didn't know that, you guys can kind of picture in your heads, would a circle pass the vertical line test? The answer is no. Okay, but if I tried to get that y all by itself, I end up getting y equals plus or minus the square root of 7 minus x squared. Now, the significant thing here is if I substitute anything in for x, for example, let's put in 2. Okay, I get 7 minus 2 squared, so 7 minus 4, the square root of 3, but I have this plus or minus. So that tells me that an answer of 2 maps to both radical 3 and negative radical 3. So we would say this is not a function. Now on the other hand, one thing we will learn later on is that this right here is what we call a parabola. And if I'm trying to get y by itself, I would get y equals x squared minus 5. This time, if I substituted in something like 2, I would get negative 1, and that's the only value. So this is a function. I'm just using that shorthand just to make life a little bit easier here. Now, we're not going to deal with this a ton this year. We see this more in pre-calc, but I just wanted to make you guys aware. Okay, so finally you're thinking it's time we're getting to examples. So what we're going to do, we're going to determine are these functions, and then we're going to list both the domain and the range. So our first one are a bunch of ordered pairs. Now, I actually don't need to graph this to show it, but I will just to be safe. I'm actually going to go through all 3 methods that we know to prove if this is a function or not, just to demonstrate. Just so you guys know, you only need to know one method for each particular problem. We don't need to try all 4 that we know. The first method we learned was checking to see if the x value repeats. Here it does. Notice I have all these different y values. So right away, we know that this is not a function. Okay, if we were using our vertical line test, I would graph these 3 ordered pairs. So I have those graphed. As I go straight along, I notice, when I hit 2, I'm touching more than 1 point, so this would not be a function. The third method is mapping, and that would be to put all of our ordered pairs, their domain in the first oval here, our range in the second oval, and let's map them. So the first ordered pair is 2, 3. Our second one is 2, 4, and our third one was 2, 5. So we can see by looking at this that each specific x value here, this domain, has more than one arrow, it has more than one output, so it is not a function. The final thing we're going to do is list our domain and our range. Now, most of the time when we're listing domain and range, we are going to use interval notation, which we learned last chapter. This one, though, is kind of odd because it's not continuous. It's just very specific ordered pairs. So our domain here is just 2, and our range would be 3, 4, and 5. Okay, since they're just ordered pairs, it's not all those values like in between there. It's just those 3 points. So we would go ahead and set it up. Notice my fancy brackets here. That denotes a set. Example number 2. Okay, I'm going to model all 3 ways again for this one. If we look, I notice all my x values are different. So we know that this is a function. Now let me go ahead and graph these. So now that these are graphed, if I'm using the vertical line test and I'm going straight across, at each point I only have one ordered pair that's touching my vertical line. So once again, we would say this is a function. Last way I'm going to show is with mapping. So we said the ordered pairs were 3, -1, 4, -1, and 5, -1. Okay, what I want to point out here, even though all these arrows are going to -1, this is a function because each domain value, each input only has one output. It only has one arrow coming from it. So when we write our domain here, I'm going to use the same method we used last time. Our domain would be 3, 4, and 5. And our range would be -1. So when we have ordered pairs, that's really all we need to do to find if it is a function or not and list our domain and range. Number 3, looking at this one, we have a graph. And so if I'm going through this, I'm using my vertical line test, and I'm noticing at every single point, my line is only touching one point on the graph. Okay, that means each input only has one output. So we would say function. It is a function. Okay, now our domain and our range here. Okay, so I have domain and I have range. For our domain, even though we don't see it, whenever we have a graph that goes all the way to the end, that means that it continues forever. So this time, I can't just list numbers because it's all these values that are on this line. So we're going to use what we used with our number lines and interval notation. So I need to think, what is the smallest value? And then what is the biggest value? Well, since these are going forever, we would say our domain is from -infinity to infinity because the line continues forever in both directions. Every x value works. So we would write -infinity to +infinity. Now with our range, we only have one y value, which is 5. It is included, so I'm going to write it with our brackets. Okay, so this is telling me 5 is the only number that works. Okay, looking at number 4, once again, I'm going to use my vertical line test, and as soon as I hit this line, we're pretending this is at -6. I'm running into all sorts of problems because there's definitely more than one point that my vertical line hits. So I would say that this is not a function. So now if I'm figuring out the domain and the range, our domain this time is only one number. It would be -6. Our range goes up and down forever, okay, because we see that we have arrows right here. There we go. And up there. So our range is going from -infinity to +infinity. Functions can be represented by an equation in two variables. For example, wait, let's pause a second. What the heck is this? What is that strange notation? This is actually what we call function notation. And the way that we read this is f of x. Okay, when we're talking about this, f is the name of the function, and x, whatever's inside here, is our input. Okay, now, often we'll see f of x, and it looks confusing, but all f of x means is the output, and we know that the output is just y. Okay, so f of x is the same thing as saying y. Okay, back to the regularly scheduled notes. As we were saying here, f of x equals 2x minus 7 means the same thing as y equals 2x minus 7. When we graph functions, keep in mind, today we're going to see some functions you know how to graph and some functions you do not know how to graph. So we need to make an xy chart. Remember, x values are inputs, y values are outputs, and a linear function, this is a new term for us, a linear function is a function that forms a continuous straight line. It has the same slope over the entire function. So on these problems, what we are going to do is graph the function. Then we're going to go ahead and practice writing the domain, the range, and determining if it is a linear function. Okay, so our first function, f of x equals 7x minus 2. First thing I'm going to do here is just to remind myself that f of x means y. So I rewrote this as y equals 7x minus 2. Now some of you might remember our shortcuts to graphing, and we're going to talk about that next class or next lecture. But today we're acting like we don't know how to graph. So what I want to do, I always want to choose a positive, a negative, and a 0. I need at least 3 ordered pairs because any 2 ordered pairs form a straight line. 3 ordered pairs will give me a better idea of what it looks like. And if I'm in doubt, I should add on more ordered pairs. I don't know about you, but I would prefer to not have to deal with huge numbers. So I normally choose -1, 0, and 1 as my x values. Okay, so I'm going to substitute those in, and I'm going to show you a new notation here. So this says f of -1. -1 is my input, and what that means, in f of x, wherever there was an x, I'm replacing it with -1. So when I do that, I end up getting 7 times -1 minus 2, which is -9. So that means my output is -9. So I'm doing the same thing here for f of 0, f of 1, and these are my ordered pairs that I am getting. So here are 3 ordered pairs that are on this line. Now remember, there are more than just those 3 that are on that line. Okay, but these are the 3 that I'm going to use. So now I'm going to plot those 3 ordered pairs. So just a reminder, something like -1, -9 means that I'm going to the left one and down 9. So I'm going to go ahead and put an ordered pair or a point right there. My next ordered pair is 0, -2 means I'm not moving right or left at all. I'm just moving down 2. And lastly, 1, 5 means I'm going to the right 1 and up 5. So I'm going to put that ordered pair as well. And now I'm going to try my best on my iPad to draw a straight line connecting these 3 points. Okay, so I think that's pretty good for being on my iPad and not using a ruler. But as we can see, all 3 points are on that straight line. It does look like this is a constant slope. It is rising the same amount. So I would say that this is a linear function. Okay, final thing I want to talk about is domain and range. Our domain, if we're looking from left to right, this arrow is going down, but it's also going to the left. This arrow is going right to the right, but it's going up, but it's also going to the right. So we would say our domain is from -infinity to +infinity. That's telling me that every single x value is a solution or has a solution on this graph. It exists on this graph. Okay, we know range are the y values, so I'm going to look down, and it's starting going all the way down to -infinity, and it goes all the way up to +infinity. So I'm going to write -infinity to infinity once again. Our next function, f of x equals x squared. Once again, I'm going to try the ordered pairs of -1, 0, and 1. So let's test this out. When I substitute in these ordered pairs, notice I made sure to substitute in with parentheses, and I got -1, 1, 0, 0, 1, 1. So I'm going to look at these 3 ordered pairs and plot those on our graph. So let me bring our graph over. Okay, -1, +1, 0, 0, 1, 1. Now, based on this, I can definitely tell that it is not forming a straight line, okay, because I have this point over here. So I'm not quite sure what that looks like, so what I need to do is try some more ordered pairs. So I decided to try 2 and -2. When I square 2, I get 4. When I square -2, I also get 4. So I'm going to go ahead and put those on our graph as well. And when I connect these, it actually forms what looks like a U shape. And we call this graph a parabola. We are going to learn a lot about parabolas this year, and we're going to learn more specific stuff about it. Okay, but that is the general look for that. So now we need to determine, is this linear? And we're going to say no, it's not linear. If it was linear, it would have the same slope over the whole point. We can see that only 2 points connect a straight line here. Every other point is not on that same line. Our domain, okay, it looks like once again it goes from -infinity to +infinity because of these arrows. Now, even though it doesn't ask us for it, I want to find the range. So if I'm looking at our graph If I look down here, we're used to arrows going down. Here, I don't see anything. In fact, as I work my way up, the first y value where there's an ordered point is at 0. At 0, it is a solid line, so I'm going to use a bracket. It continues all the way up, and these arrows tell me that it keeps going. So we're going to say that the range is from 0 to infinity. Our last set of notes here is telling us to evaluate the function and decide if it is linear. Okay, so the first part, it is telling me f of x equals x squared minus 3x plus 1 when x equals -2. So what this is telling us to do is to substitute 2 wherever there was an x. Now I'm following order of operations, and I would get 4 minus 6 plus 1. -2 plus 1 is -1. What this actually is, this is the y value when x is equal to 2. So it's like an ordered pair of 2, -1. Okay, and if you were giving me an answer, you could either give me -1 or you could give me the ordered pair. Either way, it doesn't matter. Second thing we need to do is to decide if this is linear. Okay, looking at this, and one thing we're going to learn, things that are linear are often in forms that we're used to where exponent of x only has a degree of 1. Okay, so if I look at this, we see that squared. Okay, if we look back at number 6, we saw a squared formed a U shape. So we would say this is not linear. Another way we could check this is by putting in more ordered pairs. So putting in more x values, getting the y value, and plotting a graph. Or, after we're done with number 8, I'm actually going to do a short demo on graphing in our graphing calculator to give you an idea how we could input that in our graphing calculator. Okay, number 8, f of x equals 3 times the absolute value of x minus 4, when x is equal to -3. So I substituted in -3 wherever there was an x. In this case, there was only one place. So if I'm working through this, I know the absolute value of -3 is 3. 3 times 3 is 9. 9 minus 4 is 5. Or we could have said that this was -3, 5. Now, I'm letting you guys know this is not linear either, because an absolute value is going to form a V shape. Okay, we learned if something is squared, it forms a U shape. Absolute value forms a V shape. And even though this is straight, it's not the same slope over the entire domain. Okay, so that's what gets a little bit confusing on that one. And once again, if you keep watching, I'm going to transition into our lovely graphing calculator. Okay, so I wanted to talk a little bit about our graphing calculator. So here we go. Here is my beautiful TI-84 Plus. And some of your guys' looks even cooler than mine do. Okay, so before we get into graphing, some of you guys may have watched the graphing calculator video that I've made just on graphing, and I would advise doing that if you need more help. But I want to talk about a few major things that you guys keep asking about. First, the biggest question I get is, how the heck do I do fractions? So let's say I had a fraction like 5 over 7. I'm going to use parentheses, 5 divided by 7. Okay, the reason why I need to use parentheses, I need my calculator to understand order of operations. So looking at this, 5/7 is combined in there. And let's say I'm subtracting 1/2. So 1 divided by 2. Okay, so order of operations is telling us that this 5 divided by 7 should be together. This 1 divided by 2 should be together. So now I'm going to press enter. And it gives me this crazy decimal, and we know that we should give exact answers, and this is not exact. So I need to figure out how can I put this as a fraction. So I'm going to press the math button. And this first option right here, frac, I'm going to press enter. What that's doing, it is converting any rational number into a fraction. Remember, we learned rational numbers are any number that can be written as a fraction of integers. So I'm going to press enter, and it magically tells me it is 3/14. I think this is one of the best things your graphing calculator possibly does. Okay, the next thing I want to go through, I know this happens to me sometimes. I'm typing something into my graphing calculator here, like 5.8 plus 7.3, and I'm pressing enter. And then I realize, shoot, it was supposed to be minus, and so then I retype everything, which sometimes isn't difficult, but I just want to show you a quick shortcut. If you press second entry, it gives us our previous entry. And then I can scroll over using my arrow buttons and change that to a minus and press enter. Now, let's say I wanted to find the square root of that. I would do second square root. Okay, now typing -1.5 isn't that difficult, but if it was a decimal that was longer, okay, and by the way, this is going to be like an imaginary number, which we haven't learned yet, but if I want to get the previous answer, I would press second, and then this negative symbol, and it's going to give me the previous answer. And notice it tells me, okay, that doesn't exist. It is not real. But the whole point there was to just show us second entry gives us what I already typed in. Second answer, which is that negative symbol down there, gives me my previous answer. Okay, final thing I'm going to show you guys today on the graphing calculator is how to graph using your graphing calculator. So I just want to highlight these 5 buttons. Those are all dealing with graphing. Okay, the other button that we are going to be using a lot today is this button right here, x, t, theta, n. Whenever I want to substitute x in for an equation, that is the button I'm using. So I'm going to press y equals. Let's say our function was something like 2x plus 1. Okay, notice in order to graph things in our graphing calculator, it needs to be isolated for y. Okay, now when I graph, I'm actually going to press this middle button, zoom, and there's all these options which we will get into later. But the one that I'm going to use is zoom 6, which is zoom standard. Okay, what this does for us, it gives us a graph that is 10 by 10. So when I press zoom 6, we can see our graph there is graphing. Okay, and this is one way that I could actually see if something is a linear function, if something is a function. Now, there's all sorts of cool things that happen. In fact, if I press second table, it gives me all these values, like x and y values, inputs and outputs for our graph. But what I'm going to show you guys more, I'm going to press graph now to get back to the graph. I'm going to show you this function that is trace, which is right here. Okay, notice I have this area right here that's blinking. It also tells me an x value and a y value. I can use my arrows and it continues on the function, up and down, and it gives me ordered pairs. The other thing I can do, if I want to know what an output is at a specific input, for example, 4, I'm going to press 4 and then press enter. And it tells me, oh, well, when x is 4, y is 9. And even if I do something that is off the graph like 5, it tells me it is 511. Okay, there's also all these options where we can change what we call the window, which makes our graph bigger or smaller depending on what we want to see. But I just want to go through basics today. So once again, let's press y equals, and I'm going to clear this one out. Okay, I'm going to clear my key history as well right now. Let's say I was graphing x squared, so I'm going to go x, and then I'm pressing the x squared button, And I'm going to go zoom 6, and we can see the graph there. If I press trace once again, I can go ahead and go up and down this graph and see the different values. Okay, like we did 2, we can see it's 4. We did -2. Okay, the problem there was it hit the subtraction instead of negative. So I'm going to quit and go back to our graph here. So I'm going to press graph. And we were in trace. Okay, so if I press -2, there we go, we would get 4. Okay, so mine's being weird because I'm using the keys on my computer, but the thing I want to learn from you guys to learn from this button down here is a negative symbol. This is subtraction. Okay, so that's a super brief thing on graphing. If you want more details, please watch the full graphing video that is available up on my Olu for your viewing pleasure.